All right, here's an example that's meant for class 24. We're going to do the parallel axis, use the parallel axis theorem and to make a composite moment of inertia. This is like the first example here. I might actually skip this one because I kind of prefer this example right here. So this is the one that we're going to do. It's missing a 0.5 is supposed to be right there. Let's do this by hand and then make an Excel spreadsheet out of it. All right, so all right, so there's that thing actually already done. I changed what the figure looks like here. The first thing we have to do is find the centroid, right? Because we want the moment of inertia about the centroidal axes. So there's like two of them we have to find. And we can make, I could try to make a really large table, but it's kind of better to make them into smaller, little smaller tables as opposed to making some huge thing. All right, so what I'm going to do is I'm going to write down the parameters. I'm going to do it similar to how I would do the Excel spreadsheet. So I'm going to divide it into parts. I decided to make that right there and call this one 1, this one 2, and this one 3. And so I want my X parameter and my Y parameter in a table for all these, and then I'll find what the area is of each one. Then I need to have like the distance from the reference, and the reference axis will be this right here. So this is the X reference, and there's the Y. So this is the bottom corner is the origin. So we'll get the distances from there, and then we'll take these, multiply them, and then make columns, sum up the columns. So I think I'm going to give myself enough room, but you know, it's always a sort of a guesstimate, and maybe you take a little bit of a risk by establishing how wide the columns need to be. Depends if you're going to put write out the equations inside the columns, which is often a good idea. So for 1, we have 3.6 wide, 0.5 tall. For 2, we're going to have 0.5 wide, 3.8 tall, and for 3, we're going to have 1.3 wide and 1.0 tall. Let's see, I'll put in my row lines right here. Try to make them parallel. I could be using the see-through part of the ruler to double check that they were. That's pretty good though. I could do this in my head. 3.6 times 0.5 is 1.8. You know that. This one right here, you could also do this one in your head, right? Because it's 1/2 of that, so it's 1.9, I think. And this one you could do it in your head. So we get the area right in there. And then we multiply these by each other, and I can just quickly go through there. I could do it by hand if what I want to do, I need to write down the X dot. All right, so the X dot is going to be 1/2 of that 3.6, so that's 1.8, and 1/2 of the 0.5, right? So that's the distance right here, 0.25. Same thing up here. This is 1/2 of this, 0.25. And now we need 1/2 of this, but then plus that, right? Because that's where we're going to have, so whatever that turns out to be, it's 3.8 or half of 3.8. Do we get that? Yeah, I think so. Yeah, okay, so that's 1.9 plus 0.5. Sure, so that was the 2.4. And then this guy, half of 1.3 turns out to be 0.65, and then we need half of 1 but plus 3.8 and plus 0.5, so that comes out to 4.8. Then you multiply that one times that one to get there, and so forth, right? So 3.24, 0.450, and 0.475, and 4.560, and 0.845, and 6.240. Now, yeah, add up the areas, and you get 5.0. You add up this 4.560 add up this 11.25. So if you want the x bar, we take that 4.560 divided by 5, and we get 0.912 inches. Y bar, we get 11.25 divided by 5, and that's 2.250 inches. All right, so now what we want to do is we want to find the moment of inertia. Let's just do the x one, right? We could try to do this all in one table again, but it often gets to be a little bit messy here. So let me do my manual zoom out. And so I'm going to reference the things up above. I won't repeat them. So I have one, well, let me see. I want to get my IX, right? So that I bar XI, right? Move that down just a little bit. So that's going to be BH cubed over 12. So the base is going to be 3.6 and H is 0.5. So over 12, and we get 3.750 E minus 2 out of that. So I guess I did it by hand here, even though I have my ruler sitting right there. And I just might use an extra piece of paper for this. Right now I was going to try to squeeze it in there, but it's not worth it. So the base of this one is 0.5 and the height is 3.8 of that section right there. So that's 0.5 and 3.8 cubed, and we can expect that to be a bigger number than the other one. And there's I think this is a really important thing to think about when you're making these things, is make sure you're looking at the relative contribution of each of the parts to the whole. The base here is 1.3 and the height is 1 inch, right? So BH cubed, and so it's that cubed, and we get 0.1083. It makes sense that this is a larger number because this thing is vertical and we're doing it about the horizontal, right? That's what each of those means. Now what we want to do is we want to figure out how far this thing has to move from its centroid to get to the new centroid. But it's got to be careful here. Even though this is x, it's the y distance that we care about, right? Because like here's the individual centroids of these things right here, but they're going to move somewhere down, right? So it's 2.250 is where the location was. So it's actually going to be a little bit below the center of this one, right? The center of that one was 2.4. This is 2.24. So that one shifts down. That one shifts down. This one actually shifts up. Now, I often will make the absolute value of this, but I'm going to leave it alone here and go ahead and just subtract the two out. So 2.25. Actually, in Excel, we end up getting negative numbers, but they get squared, so it doesn't matter. But here, I'll do it the same way each time. I will take this right here and subtract out that, right? So 0.25 minus 2.25. And we can get that. It's going to be 2, right? Negative 2 in this case. And then we take 2.4 up here and subtract out 2.25. And that ends up being 0.150. And then we take our 4.8 and subtract out 2.25. And we're left with 2.550. Now what we want to do is take the area of each piece and multiply it by the distance that it's got to move, but it's got to be squared, right? So it's 1.8 times negative 2 squared. We find that's going to be 7.20. So that's a pretty large number. Right? Think about it compared to that, right? So this so far this guy's really winning, and it's really because of the distance this thing is away from. Let's I'll estimate a neutral axis is somewhere like right in here, right? That's sort of where the centroid is passing right in there. And so, okay, so we're continuing on. We take the area here, which was 1.9, and multiply it by 0.15 squared, and we end up with, this is a pretty small number, 4.275 e minus 2. So it didn't really do much by moving it because it wasn't moving very far. And then we're left with 1.3 from right here times 2.55. We can expect this to be a relatively substantial number, 8.453. Okay. Now I'm going to add these together. Add this and that together. So you can see 7.238, and these two added together only changes it a little, 2.329, and then down here we put these together. It comes up to 8.561. Add them all up, and I get 18.13, and these are inches fourthed. Right, so we get IX. That total is 18.13 inches fourthed. Now let's do it in Excel. So I'm going to create a new Excel spreadsheet. And put it into here, right? Now, just to sort of maybe help myself here, let's see, where are my notes? I'll go to this guy here. I'll grab this out, and just so I can have something to reference as I'm doing this. And maybe I'll make this cut a little bigger because there's no reason to make it small. All right, so I'm gonna label this very similar to what I did above, but I'm not gonna bother with subscripts, but I could make use the subscript thing. But A, I, and I'm going to go X, and I'll write bar I, and Y bar I, then AI times X bar I, and AI times Y bar I, and then I have 1, 2, and 3 of my parts. Formatting. Make that in the center. I'll even put in lines right in here. Okay, and I'll enter in my numbers 3.6, 0.5, 1.3, and 0.5, 3.8, 1. I can take the area by multiply that times this right here, right? And here's a quick trick. Double click on that little corner, bottom corner. It'll fill in the rest for you. Here, the X bar I believe, okay, so it's easy enough in this one. You can actually, you could just take all of those X's and divide by 2. That's only because all of these edges touch next to the thing onto the side. So don't just automatically take this one. But in this one, you can do that just because they're, all right? So don't be fooled into just turning your brain off. You just can happen to take advantage of this. And then this one right here, though, we can, on this first one, take that Y and divide by 2. But on this next one, we take this Y, divide by 2, and we have to add in that Y, right? So we're taking 3.8, dividing it by 2, boom. And so this spreadsheet will only really work for this. Filling these cells out this way will only work for the shape, just to make sure you know it's not making a universal tool here. And then we take this one and divide by 2, and then we add in this, but we also add in that, right? Boom. And now we can take this multiply it by that, right? And by copying it down here. And I think we can also, no, we have to do a type of thing in here. Okay, we'll take that, multiply it by him, boom, yay. And now we want to get the summation of these. We can go up to this auto sum. We could also just type out sum if we want to, right? And do it again. We could also just like Control C and Control V if we wanted to right here. If you want to see more sig figs than that, come up to here, expose them, double check them here. Now I'm going to go ahead and put like a little thing right here. I want to write out what these are, so I'm just picking a spot, right? X bar is equal, Y bar is equal, and so this is just a convenient spot. Take that, divide by that, take that, divide by that, boom. And these are the centroids. Now, I think I got a couple people sending me emails, and it is my office hours, so I have to put this on pause for a second. Let's see, office hours, yes. Pause. Boom. Okay, it's as if no time has elapsed. Okay, so if we were going to do this correctly, we probably would also put in what the units were for all of these, right? So that's going to be inches squared, and this is going to be inches cubed, so it would be that, and then these are just inches right here. And it's good to be like consistent, thorough, that kind of thing. But anyway, we're going to make another figure down here. I'm going to make another table, I should say. And I decided to go with I bar XI. Abarxi. I don't know. Let's not try to pronounce that. And then I said DYI. Got to be careful that we don't use DXI. We could be very tempted to. And then AI times DYI squared, and then we could write E bar XI, this was terrible, plus AI times DYI 22. And because that's so ugly, I'll just go ahead and wrap that text. There you go. And make all those centered. 1, 2, and 3. And let's see. Put all those down there. All right. So here we're going to go equal to BH cubed over 12. So the base is this times the height, but we're going to cube it and divide by 12. Boom. And double checking. Yep, these look like the same values. My DYI, I'm going to take my Y bar I and subtract out my Y bar. Now, I want to copy and paste this, so I'm going to hit F4, and that puts the dollar signs next to it. By the way, you can just keep hitting F4. You can see you cycle through that, or you can just manually enter in the dollar signs. But anyway, by doing that and copying it down, it keeps that cell always at that spot. And now we want to multiply our area times this squared, right? And because the areas are located this way, I think I can copy this down, double check my numbers. Yes, they're the same. Equals this one, whoops, not times, but plus that one, boom. I get a sum, and I get, lo and behold, the same values. And I should have done that same thing that I was doing up here, where I'm going to inches fourthed, maybe inches here, and then this is also inches fourth, and this is inches, boom. So here is like the answer. It's always good to like maybe put something around it to make it clear that that's the thing that you wanted to get. Maybe even make these two something that you might emphasize the thing. And so if we wanted to double check ourselves here, what we could do is go to our handy dandy SolidWorks, and it's in inches, so that's good. So I'm going to create a sketch in here, and I think I'll just draw the thing out here. Let's see. It looks like that. That. Something like that. Boom. Something like that. And boom. Okay. Didn't mean to do that. Let's see. And I'll get my overall dimension. Maybe just use the dimensions that I have on here. Then I don't have to think too much, do I? I know that was 3.8, 3.8, and this was 0.5, and this was 1, and this distance was 3.6. Whoops. Gotta be careful when you do that type of thing sometimes. Alright, so now we come back. This thickness was 0.5, wasn't it? And this guy was 1.3. Boom, everything is black on this. Okay, so I'm just going to extrude it out. Don't need to even have any kind of like particular length of extrusion here. And let's take a look at our evaluate, and we can see section properties. Oh, it came over here on my other screen. There you go. I select that and hit recalculate. And so for the moments of inertia at the centroid, you can see that I have 18.13. So that matches up with hand calculations and the Excel spreadsheet. If we were to do the Y direction, which isn't really too much more difficult, just have to do a little bit more work, you would get, we would be able to find it here. So why don't I just go ahead and do that while I'm here. I'll do it in the Y direction. We can almost like, I'm only copying this because I'm lazy, right? And none of these values are going to be correct. But I'm going to change this to Y, change this to X, and change this to X, and change this to Y. Did I save myself anything by doing this? I don't know. Probably not. So here it's going to be B times H now, right? They swapped places, divided by 12. BH cubed over 12. Boom. And then this one is going to be this minus that, right? But we want to always be copying when we copy down, we want to always be referencing that same cell. So we'll put him into place, and then we want to take this area and multiply it by him, but he's got to be squared, right? And we need to add these two things together. Sum those up. 4.5079. How do we do? 4.51 right here. That's the one, the LYY. That's the way that they make it. It's the diagonal. There's also ones that you could do. You can't have axes that are diagonal to this. That's why there's other offline ones. But the ones that down the diagonal of this matrix, if you will, they will tell you what the moment of inertia is. Well, what we really care about is these two right here. And then you also see that these ones right here is about the output axis. So that would be, as we started at the origin, it would be about this and this. So there you go. There's the Excel. It's not terribly difficult or impossible to do. Just a little bit of time consuming to figure all these different things out as you're doing them. By the way, to print these, right, and make them nice and neat, highlight all this, go to Page, Layout, and go Print Area, set the print area. Hello? Yeah, just a moment, okay? And set the print area, and then go to Print, and oh, it works. Okay, so everything fits. If that didn't fit, or if you might want to change, you could do the page setup, and you could set it to fit to a certain area. You could change it to landscape if you wanted to, if things didn't work out the way that you wanted to fit. So there you go. There's a completed video. Took 25 minutes, but it gave you the big picture on how to do. Make one of these problems, get the Excel, do the SolidWorks, and make the comparison to them. So thank you, and have a great Thanksgiving.